Hello friends, welcome back to Breath of Its program, presenting Insight Fellowship Program in Advanced Analytical Problem Solving Expertise. And as we all know, we are in the middle of certification of Six Sigma Green Belt. I'm Santosh Naneshwar of Circuit. Yes, we have covered first two phases successfully. First was a defined phase and second was a major phase. And now we're going to enter into analyze phase. So let's recap very quickly what we covered in last two phases. Next slide, please. Right, so define phase, all we did is we diagnosed the problem and then we prioritize the problem. That is the first thing. Then once prioritize the problem, we quantified the problem. That is the second thing. And then we set improvement goals for given problem to improve. That is the third thing. Then we documented the problem. Once we done that, then we try to find out where actually the given problem is located into the process. That is the fourth thing. Once that is done, we are done with the define phase where we did two things. One, we try to find out what is the key problem to work upon. And second is where the problem exactly lying in the process. We try to find it out. Once that is done, we enter into measure phase. In measure phase, as the word measure suggests, we have to measure something. So very first thing all we did is, we define how are we going to measure the problem. So we somehow attach measurable characteristics to problem. The terms like target, specifications, and that of defectives. And as we discussed in the previous, in last couple of videos about the capability analysis, this term called defectives or the document called performance standard is one of the very important document, or this term of defective is one of the most important term around which the whole Six Sigma project is revolving. So we talked about that. Then of course, we went ahead to find out the probable causes behind the problem. So we have a problem. To fix that problem, we have to find out what are the causes behind the problem, and we need to fix those causes. But can we work on all the causes? We cannot work on all the causes, right? So to fix problems, we need to figure out what are the most significant, most important causes. And to do that, we have to follow two steps. Step number one, of course, rather three steps. Step number one, first of all, find the causes out. One. Then, based on opinions of the people who are part of that, discussions, brainstorming sessions, based on their opinion, try to find out critical causes through CI matrix. That is the second step. Once we found critical causes from the CI matrix, we will go ahead and collect the data. This is CI matrix based, finding the critical causes out of the list of these probable causes. So once we found critical causes and project Y, we just go ahead and collect the data for critical causes and project Y. Once we collected the data for critical causes and project Y, we went ahead to find out how critical a given problem is with the help of capability analysis. Now we are entering into analyze phase. In analyze phase, all we're going to do is we're going to find out statistically significant causes based on whatever data we collected in measure phase, data for both project Y and critical causes, right? So all we're going to do in analyze phase in nutshell is we're going to statistically prioritize significant few causes from critical many causes. Critical causes are from the CI matrix, right? By using statistical testing. But right now, in this particular video, we'll just go ahead and try to figure out or try to study, try to understand the foundation of the statistical analysis, that is understanding hypothesis. So what is hypothesis? We are going to move into it. So let's go to next slide quickly. Analyze phase, right? So as we keep on talking, analyze phase is about prioritizing root causes on statistical foundation, rather prioritizing critical root causes on statistical foundations. So y is equal to fx, which x could be affecting y, that we need to find it out statistically. So when we are going to do it statistically, A, it will be more accurate and it will be prioritized one out of the critical causes. So these two things are very important. We need to further prioritize already prioritized causes with the help of CI matrix. What we did, we prioritize the causes. So from the list of prioritized causes, we will go one step ahead and again prioritize it. That's the two levels of prioritization. But this time we are going to do it through the statistical foundation. And why it is important? Because statistical foundation is relatively more accurate than CI matrix based prioritization. But we got to first of all do the CI matrix based prioritization for data collection. And once we collected the data in major phase, we'll take that data and we'll just put statistical testing and we'll find out highly critical, equally accurate causes, which will definitely have impact on the Y. Let's go ahead and try to understand it further. Analyze phase, step 3.1, test of hypothesis. So let's understand test of hypothesis. Next slide, please. Right, so before getting into testing of hypothesis, first of all, let's understand what are we doing here. We are prioritizing the causes. We started with the prioritization of the causes, that level 1, by listing out many probable causes, and then out of that list of many probable causes, we find out selected critical causes from the list of probable causes. So probable causes we found through field code diagram and root cause analysis. CI matrix help us to find critical causes from the probable causes. So probable causes to critical causes, that was the first prioritization. Second prioritization is from the critical causes to statistically significant causes. So prioritization 1 was list of many probable causes to list of selected critical causes. And prioritization 2 is list of selected critical causes to few statistically significant causes. So these are the two levels of prioritization. Level 2 is little advanced level of prioritization, and that's where we need some statistical testing. Now, to do statistical testing, we need two things. A, of course, we need some data collection, which we already did in the major phase. Now, second thing is we need to do testing of hypothesis. We need to build foundation of the hypothesis for statistical testing. Now, what is all these things? We are going to look into it on our next few slides. Let's go to the next slide. But yes, before moving to the next few slides in or on statistical terms, I do have a gentle declaration over here. See, the concept of hypothesis, p-values, and other statistical terms, which we are going to see in next few slides, might be little overdose for many of us who do not have any statistical background. Please do not worry, even if you will not understand every statistical concept here. Please trust me. You will understand it over the period of time once you start utilizing these advanced analytical problem solving skills. We can save deeper understandings of the statistics for Six Sigma Black Belt program. Don't worry, I will certify you all on Six Sigma Black Belt once you have good exposure as a Six Sigma Green Belt over next 2 to 3 years. Of course, don't worry, I'm not going to charge you for that Six Sigma Black Belt too. I'm not going to charge you for that too. After all, we all are one family, right? We are Breath Affects family, and your career growth is my responsibility. So don't worry about that. Don't worry about the Six Sigma Black Belt. Don't worry about understanding of Six Sigma and statistical concept and the deeper understandings. Right now, just focus on how to utilize those skill sets, how to utilize the tools to get statistical validation, to get p-values, understanding p-values, inferring the p-values. Now, what is p-value? Why this test we are utilizing, and what is there into this particular test, and all those things we are not supposed to worry about. Right now, please do focus on how I can learn utilizing the test. That's it. Don't get into understandings of statistical concepts if you will not be able to make it, or if statistics is something new for you. Please don't worry about that. By the end of the day, if you want to travel from one location to other, we just drive the car or simply book a cab, right? That's what we do. We don't worry about engine designs and fuel mechanisms and all those things. We save it for engine designers, right? We simply prefer enjoying driving our journey and reaching destination on time. As the first example, let's take a second example, quite live and recent example. During COVID-19 period, we preferred taking vaccines within stipulated time span. Dose one, after a few months, dose two. That's it. That's how we took it, right? But we never worried about ingredients of the vaccines and how manufacturers are making it, right? We leave it to vaccine manufacturers because that's their expertise, right? Similarly, at this moment, let's not worry about knowing the statistics in detail. All we need to do is we need to follow two steps. Step number one is to learn how to use statistics for statistical validations. And secondly, second step, which is perhaps the most important step, is enjoy using statistics. That's it. So this is my humble request to you all. Let's move to the next slide. Yeah, by the way, since we talked about vaccine, hope you all have taken your vaccines. If not, please do take it and ensure our beloved ones also have taken their doses. Let's not lose our beloved ones to COVID-19 again. They are always very, 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 very precious in our lives, right? So please save them. So on this particular note, maybe a social note, let's go to the next slide. Right, the essence of hypothesis testing. Now, first of all, let's understand the definition of hypothesis. So, dictionary definition of hypothesis. It's kind of it's a noun, assumption. It means assumption, proposition, supposition, or even guess. That's what hypothesis is all about. So let's go to the next slide to further understand the meaning of hypothesis in statistical testing. Next slide, please. Just a moment. Right. So next slide, please. Right. The essence of hypothesis in Six Sigma, our hypothesis or assumption or guess is we are making some hypothesis over here, and that is one or few of critical x's that we segregated in CI matrix have statistically significant impact on Y. That's what an assumption we are making over here. Now, this hypothesis or assumption may be right that X or few of the X's do have an impact on Y. It's maybe right, maybe not right. So there is no impact on any given critical X's on Y. There's a possibility of this. Now, third possibility is may be right only for given 1 month's major phase data collection, which we did in a major phase, and had we collected data for other months other than that 1 month's data which we collected in a major phase. Had we collected data for other months, perhaps it might not have been right for those months data collection, or it might be right for those months, those whatever months had we collected the data for. Like Shakespeare's famous quote, "To be or not to be." So kind of a confusion, or kind of a confusing situation. Now the thing is, can we collect data for all those months to verify our assumption? We have collected data for 1 month, and based on that 1 month, we want to make some inferences, right? That's fine, we can see it. But again, there is one doubt in the mind. What if we have had we collected data for some other months, what would have been the results? Either positive result or negative result, and we are not sure about that. Now the question is, can we collect data for all those months to verify our assumption? No, we cannot, because Six Sigma project need to be completed within planned timeline. So that's some restrictions, or that's a limitation we do have. In 4 months of time, we have to finish Six Sigma project. So in that particular situation, how to verify whether any or few of the critical excess have statistically significant impact on Y for all those months where we have not, or we were not in a position to collect the data. How are we going to verify? Answer is hypothesis testing. Let's go ahead and try and understand hypothesis testing much deeper. But right now, to sum up, we need to understand the current situation that we cannot collect data for n number of months, and we want to make assumptions or predictions for a performance for those n number of months based on 1 month's data. How are we going to do that? First of all, can we do that? Hypothesis testing helps us in that case. Let's go to next slide quickly. Next slide, please. Right. So what is testing of hypothesis? Hypothesis testing is a statistical method that is used in making statistical decisions based on a given sample. Now here sample is 1 month's data. So based on that given sample of 1 month's data, we're going to make statistical decision for the whole population. Now what is population in this scenario? Population in simple words is data collection for those many undefined number of months that we unfortunately cannot collect. So population is those months, and we want to make inferences about those undefined months where we couldn't collect the data, and sample is 1 month's data, specifically major phase data, right? So 1 month's major phase data, that's the sample. So based on that sample, we want to make a predictions, we want to make inferences for all those months where we haven't collected data. By the way, we are saying that we are collecting data for 1 month. Can we make a prediction based on this 1 month's data for 6 to 8 to 9 different months, or for that matter, one whole year? Can we make a prediction for the time span of the one whole year's data? We cannot do that. Can we collect data for 12 long months when Six Sigma project's timeline is only 4 months? How can we collect data for 12 months for major phase? We cannot. So that's where the problem comes over here, and statistical testing or testing of hypothesis help us over here. In other words, based on sample-based data analysis, hypothesis testing make inferences for whole population, as we cannot define how big a population can be. And that's the power of hypothesis testing. Based on a small sample-based data, we make a prediction for the whole population. So statistically, they say based on 5% of the data from the population, which is called a sample. Sample is roughly 5% representative to the whole population. So based on 5% of the data which we collected, if you want to make a predictions or inferences for rest of 95% of the data, that is population, hypothesis testing help us over there. So that's about the essence of hypothesis testing. So let's go to next slide. Right. So how are we going to state the hypothesis? So stating of the hypothesis. So hypothesis always comes up with two opinions. One is null hypothesis, and another one is alternate hypothesis. So in case of Six Sigma projects, null hypothesis is critical excess that segregated from CI matrix have no impact on Y. And when I'm saying no impact, no statistically significant impact on Y. That's what the null hypothesis is. Alternate hypothesis is always opposite to null hypothesis. So what would be my alternate hypothesis? That is indicated by HA, and the null hypothesis indicated by H. H naught, we call it H naught. So H naught and HA. HA is one or few critical X's that segregated from CI matrix have significant impact on Y. So let me read H naught or null hypothesis and HA, which is alternate hypothesis again. So what is H naught over here? So if I'm going to call it H naught, please do remember I'm talking about null hypothesis. And if I'm going to say HA, please do remember this is alternate hypothesis. In case I'm going to call it that way. So H naught over here is critical X's that segregated from CI matrix have no impact on Y. Alternate hypothesis, one or few critical X's that segregated from CI matrix have significant impact on Y. So let's go to next slide. Right. So once we understood how to state the hypothesis in null as well as alternate hypothesis, let's go ahead and understand how we are going to implement or execute hypothesis test. It comes up with different steps. So let's understand those steps. So steps of hypothesis test. Steps. Step number one, state the hypothesis or question you want to answer, what we really want to find out, that given critical X's do have impact on Y. That's what we want to testify, right? So step number two, write null hypothesis. What is null hypothesis, which we already have seen on a previous slide, right? So critical X's that segregated from CI matrix have no impact on Y. That's a null hypothesis. Third step, write alternate hypothesis. That is, one or few critical X's that segregated from CI matrix have significant impact on Y. Then step number four, select appropriate statistical test for validating hypothesis. We need to select right statistical test. So which test are we going to select? We are going to say chi-square test for our Six Sigma projects. Let's go to next step. So before we just go to next step, let's recap one more time different steps we're going to take while executing hypothesis test. Starting with state the hypothesis, then write null hypothesis, then write alternate hypothesis, then select appropriate statistical test. Let's go to next slide. Yes, step number 5, run the test in Team Breadth's statistical tool. The tool which we're going to provide to you is our tool, right? It's our family's tool. So you can use it. You have the right to use that tool for your Six Sigma projects. So run the test in Team Breadth's statistical tool. That is step number 5. Step number 6, check p-value. So we're going to check p-value. Step number 7, assess how much is the risk of rejecting H naught, that is null hypothesis, and whether we can take that risk of rejecting null hypothesis. So risk percentage, how much is the risk, how we are going to define it. Risk percentage is nothing but p-value which we are going to get through this statistical tool. We're going to get a p-value, and this p-value into 100 will give us associated risk. That is step number 7. How much risk need to be taken to reject null hypothesis. That is step 7. And step number 8, which is very crucial step, make a decision whether we are going to reject or we are not going to reject H naught or null hypothesis. So let me repeat this. Step number 8, make a decision whether we are going to reject or we are not going to reject null hypothesis. So these are the eight different steps we do have, in steps of hypothesis testing. And once that is done, we are done with our statistical testing. Let's go to next slide. Right. So decision from p-value. P-value is a probability value. Right. So if p-value is 0.05, suppose take an example after deploying test into our Team Breadth's statistical tool, you got you have p-value of 0.05. What it really means of p-value of 0.05? It means there is 0.05 into 100, which is nothing but 5%. So there is 5% risk of rejecting null hypothesis. And what is our null hypothesis? That critical x's do not have any impact on a y. That is our null hypothesis. So there is a 5% risk of rejecting null hypothesis. Means we need to absorb 5% risk in accepting alternate hypothesis. Now, what is alternative hypothesis over here? One or few of the critical x's do have an impact on a y. Right? So if you want to say by the end of the day, this is what we want to prove, that few of the x's from the critical x's, the list of critical x's from CI matrix do have an impact on a y. That is our problem. Then only we'll go to the next phase of improve, and there we'll come up with the solutions to fix these causes. And once we fix these causes, then problem will get fixed. So what we really want is this alternate hypothesis to be implemented or proven. But to prove alternate hypothesis, we need to take a risk as much as p-value into 100. That is whatever that amount will be. We need to take that much of risk, right? So let me repeat this point again. If p-value is 0.05, it means there is 0.05 into 100, which is 5% risk of rejecting null hypothesis. Means we need to absorb 5% of the risk in accepting alternate hypothesis, which we really want to do. We want to accept the alternate hypothesis, right? So but for that sake, we have to take 5% of risk. It's just like give and take kind of situation. Take alternate hypothesis, but also accept the risk of that percentage. So we have the alternate hypothesis, accepting alternate hypothesis, or rejecting null hypothesis. Both are the same thing. If you want to do that, you also need to accept certain risk. All we need to do a decision for is whether we can take that much of risk. That's it. Ideally, p-value should be less than 0.05. I mean, risk taken should be less than 0.05. So our risk appetite shouldn't be more than 5%. But it totally depends on management decision whether they want to take higher risk than 5% to reject null hypothesis. That is accepting alternate hypothesis. So ideally, our risk appetite shouldn't be more than 5%, but there is a possibility that management can take relatively higher risk than 5%. All we would suggest that if they really want to take a relatively higher risk than a 5% risk, that risk is not supposed to be more than 10% of the risk. It means if p-value is more than 0.1, they should avoid taking that risk. In other words, they shouldn't be rejecting that null hypothesis. That's it. So this is about the decision of rejecting null hypothesis. In other words, accepting alternate hypothesis based on p-value, that is probability value. Let's go to next slide, please. Right, the quiz time. Analyze phase is about prioritizing root causes on statistical foundation. True or false? And the answer is true. Analyze phase is about prioritizing root causes on statistical foundation. Next question. Hypothesis testing is a statistical method that is used in making statistical decisions based on given sample for population. True or false? And the answer is true. Hypothesis testing gives or provides the power that we can make a decision based on a sample for that of population, as we cannot work on the full population. That's the power hypothetical testing provides to us. Next question, if p-value is 0.05, it means there is 0.05 into 100 is equal to 5% of the risk of rejecting null hypothesis. Means we need to absorb 5% of the risk in accepting alternative hypothesis. True or false? The answer is absolutely true. On that note, let's go to next question. Well, we're done with the questions. Now we're almost on the verge of ending this video. So right now, we are done with analyze phase first part, that is understanding of hypothesis testing or conceptual understanding of hypothesis testing, which is a backbone or foundation of any statistical analysis. Now, in next video, all we're going to go through is we're going to go through chi-square testing and goodness of fit testing, or descriptive or graphical analysis of goodness of fit testing with chi-square testing, and that too for strategy number one. Do you remember we have a couple of strategies of data collection in major phase? So we're going to look into how we're going to use chi-square testing for strategy one, which we normally need to follow. Strategy two, let's keep it for rare purpose where senior management is not going to allow us to collect the data. In that case, we're going to look into chi-square based testing uh, for strategy two, but that too not in upcoming video, next video. But for time being, this is what we do have. So in our next video, let's go through chi-square testing and how to deploy chi-square testing. Please do remember, our focus, our goal is not right now worry about statistical understanding, but to learn how to use those simple tools, which are tools, right? Our family's tools, right? You can use it at any given time. Use it and get benefited out of it while deploying statistical analysis. So on that particular note, let's go to next slide, please. Right, so we are almost done. So as I kept on requesting you, this is the initiative. When we started this initiative, our why was to reach out to as many as of them and help as many as we could to get the job, to get the employment, and not only that, grow in their employment, right? So please help us to reach out to your friends, families, and your neighbors and your relatives, and let them know about the BreathFX program of advanced analytical problem solving skill sets. This is going to add a huge value to them, and when they will get benefited, our nation will get benefited, and that's what we really want to do. We want to contribute our share into nation building. So on that note, Uttishta Bharata, Ma Bharati shall rise again in a full glory. But before we end, as we normally do, we need to deeply appreciate following technology companies for their technological support. So we are thanking these companies for their support. By the way, please, if you like the video, please click on a like button. If you are not subscribed our BreathFX YouTube channel, please subscribe it and please share the video with your friends, families, and neighbors. So on that particular note, thank you so very much for your time. Have a wonderful, wonderful time ahead, and let's meet up in our next video. Thank you so very much.